In this video, we're going to look at a method of solving quadratic equations called completing the square. And completing the square requires you to make a perfect square trinomial. So we're going to talk about how to do that first. To make a perfect square trinomial, what you're going to be starting with is two terms, a binomial, x squared plus bx, where b is going to be some number. And what you're going to do is add the constant term, or the c, and the constant term that you're going to add, you're going to take the value of b, divide it by 2, and then square it. And then that number you add to the binomial, and your result is going to be able to be factored. So the result can be factored into x plus b over 2 squared. So not only can it be factored, but it can be factored into what's called a perfect square trinomial, where you can write the result as a set of parentheses times itself. So we're going to look at example 5 here. It says which term should be added to each binomial so that it becomes a perfect square trinomial, and then write and factor the trinomial. So we're going to look at part A. We have x squared plus 8x. So this is a binomial because it has two terms. We're going to add the constant, and so what we need to figure out here is what is b. Remember, when you're labeling the coefficients, a is in front of x squared and b is in front of x. So b divided by 2 squared is going to be 8 divided by 2 squared. 8 divided by 2 is 4, and 4 squared is 16. So we're going to add 16. So when I add 16, that's going to give me x squared plus 8x plus 16. And then I can factor this. Two numbers that multiply to 16 and add to 8, they're going to be plus 4 and plus 4. So when I factor this, I should be able to get the same set of parentheses for both. The two sets of parentheses should be the same. And if they're the same, then I can write it as whatever that set of parentheses is squared, because it's multiplied by itself. So this would be x plus 4 squared. So you should look next at checkpoint problem number 5. Do this in your notes, check your answer, and then move on with the rest of the video. So next we're going to look at example 6, where we're actually going to use completing the square to solve a problem. So we have our equation here to solve for x squared minus 6x plus 4 equals 0. And we saw equations that look like this back in section 5.7. In that section, we solved them by factoring. But notice that with this one, you can't solve it by factoring because there's no two numbers that multiply to 4 and add to 6. Your only choices for pairs of numbers that multiply to 4 are 2 times 2 and 4 times 1. Neither of those pairs add to 6. So we need another method to solve it, and this is going to help us to do that. So when you're solving by completing the square, it's a little bit different than solving by factoring. When we solved by factoring, we wanted 0 on one side of the equation, which is what we have here. When we're solving with completing the square, we want to have the x squared plus bx by itself. So the constant that I have here, the plus 4, I need to move that to the other side first. Sometimes it'll already be written in this format with x squared plus bx by itself. Sometimes you'll have to do that as a first step. In this case, I have to do it as a first step. So I move the 4 over, I have x squared, and I have the bx by itself. Next, I'm going to figure out what I'm going to add. So my b in this case is -6. -6 divided by 2 squared is -3 squared. And -3 squared is +9. Now when you're doing this, when you square a negative number, you have to remember that it's supposed to be positive. Negative times negative is positive. You should always get a positive number to add. You should never be adding a negative number to both sides. Even if your b is negative, squaring it is going to make that negative go away. And the other thing here is that since this is an equation, if I'm going to add 9 to one side, I also have to add it to the other. What you do to one side, you have to do to the other side when you're solving equations. So I'm going to add 9 to both sides. That's going to give me x squared minus 6x plus 9. On the right side, -4 plus 9 is 5. The next step is to factor the left side. And since I added 9, the idea is that this should factor very easily into two sets of parentheses that are the same. So two numbers that multiply to +9 and add to -6, they're going to both be negative, -3 and -3. Keep the 5 over here, and then I can write that as x minus 3 squared, because they're the same, which is what I wanted. Now from here, it's the same problem that we saw earlier in this section. I'm going to solve for x. To get rid of the squared, I take the square root of both sides. That's going to leave me with x minus 3 on this side. Don't forget the plus minus in front of the square root. And then the last step is to add 3 to both sides. So my answer here is x equals +3 plus minus square root of 5. And then we always want to check the square root to see if it can be simplified or if it's a perfect square. In this case, it's square root of 5, so neither one is true. It's not a perfect square. It can't be simplified. So this is my answer that I would enter into my math lab. So what you should do next is checkpoint problem number 6. Do this in your notes, check your answer, and then move on to the homework for this section.